Okay, so thank you everyone for being here. Thank you, Julia, for the kind introduction. It's a bit difficult to follow up the amazing talks that we had so far. They were very, very entertaining. But what I want to tell you about today is a story that starts with myself. So a few years ago, I was in the middle of my university degree, and in between studying and spending some time in the lab, or actually spending a lot of time in the lab, but in between these activities, I started dating a guy. And he was amazing. He treated me super nicely, and he thought I was the most beautiful person in the world, and everything seemed just perfect. Then one day, he told me he had a genetic condition that was affecting his vision. So I learned that while the world to me looked something like this was what's going on through his eyes. And finally, it made sense why he thought I was so pretty. But this got me more and more interested in his condition and in general in conditions that affect vision. Now, I found out that there are over 250 million people in the world that suffer from conditions that lead to blindness or severe visual impairments. And just for you to have an idea, this is how they see the world. So they are very, very different diseases, but what they all have in common is that they affect what an organ of our body that is called the retina, and this is located on the back side of our eyes, as you can see here. And basically, under normal circumstances, the cells of your retina are quite healthy, they look happy. And in case you're wondering, yes, I do this myself. It was not a 3 years old yet. And okay, so however, when we have a damage, a trauma, or a disease, the situation is a bit different. So the cells start dying off, they become feeling unhealthy, and what you can imagine is that the whole tissue starts screaming for help. Now, what is the solution to this? In my mind, the solution was quite simple: regenerate. So just replace the old cells, the dying cells, with new cells, and that's it, problem solved. And actually, this is what a lot of animals can do. So you all know that if you chop off the tail of a lizard, after a couple of weeks, it will regrow a new brand one, shining and no problem at all. And we also have examples from other truly amazing organisms, like this guy here, Irisa planaria, and you can chop it up into 179 different pieces, and each single piece will grow an entire new organism. So this is quite impressive. But things are a bit different for us. So we're just humans and we cannot do this. So please, please, please do not try any of this at home. I do not take responsibilities for this. And as you can see here, I also put a nice image of this is a special fish, it's called zebrafish. And I put it here because it's one of the organisms with the highest potential for regeneration of the retina. You can almost completely destroy its retina, and in a few weeks he will be back to seeing perfectly again. So I was like, if a lizard or a fish can regrow their eyes, why can't I? What's wrong with me? So the answer to this, it's really not very simple, and trust me when I see that there are thousands of scientists around the world that are trying to figure this out. But in the meantime, what we can do and what I do in my everyday life is trying to find an alternative solution. So what I do is called cell therapy. Now I'll show you what the hell is cell therapy. So the easiest way to explain it is that I place some cell here in the eye, and these cells can be seen as helpers, which means that they have the potential of helping the cells that are in need, that are in trouble. So basically when you put them there and you have, let's say, a normal healthy situation, not much happens. The cells of the retina are happy, the cells of the retina are happy, and you have the other cells here, and not much going on. However, when you have a damage, or a trauma, or a disease, the tissue, as I said, starts screaming. These helper cells can hear their friends in trouble, and what they're going to do is that they're going there where needed and help them. So far so good. This sounds pretty good, doesn't it? However, the situation is a bit more complicated than that. So, in my language, the different screens that the retina can give off are referred to as signals or factors, and the ears that allow my upper cells to hear and to perceive the screens are called receptors. So, there are a huge number of different signals that the retina can give, and they are represented here by the different colors. And they can be perceived only by very, very specific types of receptors, which means that the green receptors will not be able to respond to a blue signal and vice versa. Okay, so what is the problem then? So the problem is that most of the cells that we transplant are either deaf, which means they do not have the receptors, or they have the wrong type of color. So they will not be able to respond to the signal appropriately. So what my job is all about really is to try and understand what are the different colors of the signals that are released. And once I know this, I can provide my helper cells with the right receptors that will allow them to correctly hear what the retina is asking for. And they can go there and help them and prevent them from dying. And of course, all of this is in the hope that in the near future we will be able to help the 253 million people that are in the world suffer from this kind of diseases, even if for some of us it means stop being so beautiful.